Right, so far. My name is Damian Edwards. I'm a program manager at Microsoft on the web platform and tooling team. We're the team that make products like ASP.NET, the Visual Studio web tooling, including the editors for HTML, JavaScript, and CSS. We also are the team that do the jQuery contributions that you heard about in the talk just gone. And we also make the IIS web server that runs on Windows Server as well. So we make some pretty cool things. Personally, I deal with the editors in Visual Studio, so the JavaScript editor, the CSS editor, and the HTML editor, like I said. But my history before joining Microsoft, I only joined this year, was as a senior consultant in Australia specializing in front-end web development on large Microsoft-based websites. So I have a big passion for jQuery and a big passion for JavaScript in general. It's great to be back here. I spoke in this room a few months ago at the Bay Area .NET user group about jQuery and had a lot of fun doing that. Based on the reaction I saw originally when Bruno asked up front how many people are new to jQuery, there seems to be quite a lot of people in this room who have come really to learn about jQuery. They haven't done a lot of work with it before. They're interested in what it does. And so what I'm hoping to do in this presentation is give you a good overview and hopefully highlight some of the really good features of jQuery, but more so send you away with what you need or the things that you know you need to investigate more to become a really good jQuery developer. And a lot of that comes down to actually knowing JavaScript. So I'm going to spend a little bit of time looking at some of the fundamentals of JavaScript that a lot of people perhaps aren't aware of. And then we'll see how that becomes important when we start using jQuery, because a lot of these features of JavaScript are exploited when you start developing with jQuery, and if they're new to you, it is easy to get a little bit lost if you're not used to seeing JavaScript used in this fashion. So without further ado, I'm going to switch over. I don't have any slides. I am just code for the next 40 minutes or so. Oh, yes. Thank you. And that was it. Thank you very much. I got my applause. So I'm going to go now. So by all means, we can have questions at the end. If you've got a pressing question, yell it out or put your hand up, and I'll do my best to address it as we go along. That good? A bit too much? How's that? That's a great feature of Visual Studio, I have to say there, control scroll. It's great for demonstrations. It's really no good in general development. But don't tell anyone I told you that. So first thing I wanted to talk about is functions. Now, JavaScript is a functional language. It's many things, but one of the things it is a functional language. If you are a C# developer or a Ruby developer or any other language that has lambdas or anonymous delegates or anonymous functions or whatever your language chooses to call those things, this won't be a new concept to you. But let's start off with the really, really basic stuff. So if I declare a function in the root of my JavaScript file like this, this is what we all know and love as JavaScript developers. Every web developer worth their salt at all knows how to do this type of thing, but we'll talk about why that's bad later on. Some of the things you might not know is that you can do really wacky things like this. So in this case, what I've done is nested a function inside another function. Now this is totally fine because functions are first-class citizens in JavaScript. They are values in their own right. I can assign them to variables. I can pass them in as parameters to other functions. I can even return them as a return type of other functions. So I can do really silly things like return this function from that function. As long as I close it, and then when I execute foo, I can immediately execute the resultant result from foo because it itself is a function. And you can see people do very theoretical things with this and get really wacky where you basically have code that looks like this because you're just forever returning functions and executing other functions. Now, I'm glad to say jQuery doesn't quite go to that extent, but it does utilize this feature to some important points later on. As I said, we can pass functions in, so I can have a parameter like this, and then I can write code in here that assumes P1 is a function, and that's fine. And if I call foo, I could go ahead and pass a function in directly like so. Now, there are two types of functions that I currently have on the screen. One is a function declaration, which is this one here, which is fine. As I said, these are the ones that people generally use and know the most. And then this one here is a function expression. It doesn't have a name, so it's anonymous. It's an anonymous function expression. And I'm just basically passing this function as a raw value, similar to the way you would pass in a string using a string literal, something like this. This is really the same way of denoting a literal into this function. I can also have a sort of a hybrid, which is a named function expression. So I can do something like this. So now it's an anonymous function. Well, it's not an anonymous function. It's a function expression, but now it's named. And there are reasons you would want to do that, and we don't need to go into those tonight, but it's important to note that all of these things are totally valid in JavaScript, and they all have their uses. I won't say functions, because then we're going to start overloading terms. And wait till we get to talking about this, and I'm going to really confuse you. So that's a really basic introduction to functions. Let's have a look at objects. So objects, I said that JavaScript is a functional language, and by that I don't mean that it's useful. I mean that it actually treats functions as first-class citizens. It's also an object-oriented language, and we can get into arguments about this down the pub afterwards if you want to, but for my money, JavaScript is an object-oriented language. And we can see that very, very simply because everything in JavaScript is based on objects. Now, I can create an object very simply using something called a JavaScript object literal. Who's used JSON? Okay, so you'll know that JSON stands for JavaScript Object Notation. JSON is a subset of what is valid JavaScript object literal notation. So in JSON, you will generally see things like this, where I have my little squiggly brackets to represent a thing in my JSON result. And then I start, I have an identifier called foo, which I use a string to do that. And then I use a colon to separate the identifier from the value. So maybe my value foo is equal to 1. Then I use a comma, and I can go on and do my next value. And I can continue doing this for the values that are in my object. And in JSON, we can put these in arrays as well. So I can use an array literal. So I can surround this whole thing with square brackets like this. And even though my formatting is not great, I could then copy this, paste that in there, and now I have an array of 2 object literals using an array literal to declare the array in the first place. Let's just undo all of that. Now, this is JSON, and JSON says what you can and can't put in this side of on the left-hand side of these name-value pairs. But in JavaScript, pure JavaScript object literals, you don't need to have these quotes here to denote the identifiers. You can just put the identifiers like such. And there are certain identifiers that you are technically able to use in JavaScript object literals that you're not allowed to use in JSON. Things like reserved words and keywords that you can put in if you do things like this. While technically, in JSON, they basically forbid that to stop you getting yourself into trouble and to be forward compatible with versions of the language. But in JavaScript, you can do those things, and that's not a problem at all. So this is this thing O now is an object, and if I hit O dot, we can see that what I'm getting in Visual Studio here is IntelliSense showing me that the members of O include those things that I just declared on O by doing this object literal, my foo and my bar. So that's all fine, but I can do other things like, well, say I want to add another member like alpha. I can just go ahead and do that directly because we're not talking about a statically typed language. We're talking about an object-based language where the objects are basically just property bags, dictionaries or hash tables, whatever it is you want to call them. They're things that you can put identifiers on. That then there's a certain valid set of characters you're allowed to use to build your identifiers. And then the identifiers map to some type of value. And these can be hierarchical. So I could go ahead, and if I went back to my literal, I could put I'll put alpha on here this time, and I'll make this another object literal. And so now I can put alpha, put a member called Damian. I can make that a function. And I'll zoom out again so we can see. And we can build this object graph up as easily as just declaring how we want it to look. But unlike classical languages where we define a class, which says, this is how my objects that are based on this class are going to look, and we compile that, and that's what it said. In JavaScript, you just do it. You just write it. This is the object. This is what it is. If I want to change it, I can do that. That's fine. You can see I've declared alpha here, and then down here I've just changed what alpha is. There's nothing wrong with that. That's the nature of JavaScript. So that's object literals. But we can do other things with objects in JavaScript as well. So JavaScript, despite not having classes and interfaces and supporting classical inheritance, it does have constructors. And if anyone read Douglas Crockford? Okay, a couple of people. By the end of this, if I get time, I will surely give you some links. If you want to learn more about JavaScript, he is the guy to read. Constructors are a bit of a blessing and a curse in JavaScript. I mean, they're a necessary evil in the language, in the version that's widely supported today. In the next version, ES5, you don't really need them anymore for doing a lot of things. But today, if you want to work with objects and have things like inheritance, or what looks like inheritance, then you need to use them. So constructors aren't really special. They're just other functions. So I can say, this is my... We'll call this my, well, let's do something a little more realistic. This is my animal constructor, canonical OO sort of example. Now, the thing that makes this a constructor isn't anything that I do to the function declaration itself. So far, it just looks like any other function. But if I call this function and I use the new keyword in front of its invocation, like such, what I get as a result of invoking that is very different to what would have happened if I just called animal without the new keyword. What the new keyword essentially does is says, create me a new object that is based on animal's prototype, which is something I haven't showed you yet, based on animal's prototype, and then run the animal function over that object and then give me the result. Now, this is totally different to how people who use things like Java and C++ and C# and those statically typed languages think about constructors. So a lot of people, when they see the new keyword in JavaScript and they're getting started and they've come from that classical language sort of paradigm, either get confused or start using the new keyword in the wrong way. It's also dangerous because if you write this animal constructor, this function, with the intent that it gets called this way, then what you'll generally do is start using the this keyword to refer to the new object that you're creating. And you'll say, well, I wanted this, when I create my animal, I'm going to put this dot breed is equal to something on it, and I'm going to put this dot smells like equals to something else on it. And you think this is all fine. And sure enough, if I do f equals new animal, my f is going to have, in fact, I should be able to see that. If I say f dot, you'll see I now have an f dot breed and an f dot smells like, and everything is wonderful. But if you forget to do this, and if I instead do this, var f equals animal, bad things start happening. Instead of this referring to the object that I'm creating, this now refers to global scope. And so what I've just done is gone and put a breed member and a smells like member in the global scope, which in my browser is my window object, which isn't really what I wanted to do. So for this reason, the constructors are generally noted as a bad part or a dangerous part of JavaScript, and you have to be careful. So one of the conventions we do is we always capitalize constructor functions. This way we know when I'm reading my code that if I see anything that looks like that, where I've said f equals animal, some function that begins with capital, and I don't see the new keyword, I know immediately, because I'm, the human brain is a fantastic pattern recognition machine, that I've forgotten to do something there. And if you're using something like JSLint that we heard about previously, it will find these things for you as well, if you stick to the conventions that have been set up to do this type of stuff. So we can do that. I mentioned this prototype thing before. So if I type animal down here and then go prototype, what I can do here is say, well, when a new object is created using the animal constructor function, I want it to have these members. Other than just the members that I'm defining in the constructor itself, I want it to inherit a bunch of stuff from this thing called prototype. Now this is at the very core of how JavaScript objects work. Crockford calls this prototypical inheritance. So it's not really inheritance. It's more correctly described as behavioral delegation, because the way it works is that we don't actually, the new animal object f isn't actually getting the members that I define in here. So if I define a member in here, a function like such, and maybe I define something else in here as a string, f isn't actually getting member 1 and member 2 on itself, like you would get in a classical language where you define a hierarchy of classes which inherit from each other. You create a new instance, and essentially everything is on that, and you never go back to the class. You're now working with the object that was built from those class definitions. With JavaScript, what's happening here is it's saying, well, because it's all dynamic, when I refer to member1 at runtime, what JavaScript's going to do is go, okay, well, does the f object have member1? Well, no, it doesn't, because it wasn't added in the constructor, and I didn't add it to myself immediately to the object after I created it. But then what I'll do is, if I don't find that, let me go and have a look at animal's prototype, or this member's prototype, and see if it has that member that's being asked for. And it will keep going up the prototypical chain, because a prototype can itself have prototypes, until it either finds a member or it gets to the root of global scope and doesn't find anything anymore, and at that point you'll get an undefined, depending on how you're using that identifier. So again, prototypical inheritance, you don't need to know a lot about that to use jQuery, but this is how jQuery is built underneath the core. And if you're going to start doing any complex JavaScript applications, sometimes you will find, you might find this tool is something that you like to have in your belt if you're used to doing inheritance and object-oriented type things in JavaScript. So let's move on to the next things. Scope and closures. If you are used to working with a C-type language, you will be used to variable scope being block scope. And by that, what I mean is that if I do something like this, and I declare a variable in here, and this function is itself a block, so the var I shouldn't appear outside this block, and everything is fine. If I then do something like var j is equal to 0, where j is less than or equal to 10, and I want to j plus plus each time. So this for itself is a block, and you would expect that if I declare something in here, that x is only visible within inside that block, because that's how C languages generally work. Well, in JavaScript, that doesn't work. In JavaScript, scope is function level scope. So x is actually visible outside. And you can see that the editor here is telling me that because I'm getting statement completion for x inside this function. If I jump down outside that function, we don't know what x is anymore because the editor is actually executing the JavaScript. So it's just a good tool for demonstrating what's going on. Now, this is one of the things that trips a lot of web developers up when they start using JavaScript in anger. When they come from a C language, because everything appears to work for the first few weeks, and then you'll get your first bug that's caused by this scoping problem. So it's well worth knowing that scope is function in JavaScript. Now, okay, so that may be seen as a bad part, but it also has, we can work around it quite easily. We can work around it using closures, and we can work around it using immediately executing anonymous functions. Now that's a really long word, or lots of words, but I'll explain what I mean by that. So if scope is function level, and I mentioned before about polluting the global scope. Now, when you do something wrong, now polluting the global scope is wrong and bad for lots of different reasons. One of the main reasons is that in the browser, you can't always guarantee that the JavaScript that's running in the browser is yours. A lot of the times you're pulling in libraries from lots of different places. You may have the user running ScriptMonkey or something wacky like that. You might be using plugins, and you have to ensure that these things don't clash. Now, if all of these scripts are trying to use global scope, they're declaring members in global scope, inevitably you're going to end up in a situation where two scripts are declaring the same identifier in global scope, and you get a collision, what we call a collision. And then they're a very, very hard bug to find. So what we generally recommend people do is you never do what I'm doing here. You never ever declare a function in the root of your JavaScript file. And if you're in a document like this and you had a text block like, a JavaScript block like this, you would never ever do what I'm doing here either. You would never declare a function like this. So how do we get around that? Well, we can use these immediately executing anonymous functions to do this. So all I'm going to do is create an anonymous function. That's a function with no name, like this. And then what I'm going to do is I'm going to immediately execute it by following it with the invocation characters, open parenthesis, close parenthesis. And then to show that I'm doing something special here, I'm going to wrap, because although syntactically this is correct in JavaScript, it kind of looks funky, and we want to make it much easier for me as the developer when I'm reading my code to see that this is what I meant to do. And so I'm going to wrap the whole thing in parenthesis, which you can do pretty much anywhere in JavaScript. You can just wrap stuff in parentheses, and you can just logically group it, and it doesn't really have any effect on the scope or execution. So now what's going to happen is that anything inside of this function obviously is only scoped to this function, because variables in JavaScript are function scope. So I can now safely put whatever I like inside of this function, and as long as I'm declaring it with the var keyword, it'll stay in the scope of this function. Now you can do stuff like this accidentally, where you say I equals test. Hey, I'm inside an anonymous function, everything's fine. And what you'll find is that these things can leak out, because if you forget to declare it with a var, then things can leak out depending on how you're using these functions. If you want to pass stuff into this function, now bear in mind you can still get to the global scope. If I do this dot inside of here, this is still the global scope. So you can see I've got all my I can get alert. So that's, this is equal to the global scope, which is equal to window. So you can still get to global scope, but what's generally done instead is you want to pass in the things that you want to use inside of here rather than relying on the fact that you've got global scope access. So if I want the window, I could just pass in the window object and then pass it in as W, and now W in here is going to be equal to window. And if you look at the jQuery source, you'll see that the entire jQuery file is wrapped in one of these, and they pass in window, and then they pass in something else. Well, they don't pass it in, but they declare it as a parameter. Which is kind of cool, and if you're getting into advanced JavaScript, you can read up on why they do this type of stuff. My understanding is it's done for minification purposes. It lets them use, rather than relying on the undefined keyword, they can just rely on this. This is now a parameter identifier. It's not the undefined keyword. And so I can, when I minify this JavaScript, undefined could safely be turned into you. And because it's not passed in here, you will be equal to undefined because the parameter was never actually passed in. So you can do kind of cool things like that. But the crux of this lesson is that to avoid polluting the global scope, you want to use these immediately executing functions. Now, when we get to jQuery, we'll find there's a slightly easier way we can do this, and we'll have a look at that in a moment. Lastly, one of the things I wanted to talk about is this. And I better hurry up because they're coming to get me. This is where it gets difficult, because now I'm going to talk about this, and I want to use the word this to explain this. So bear with me. I will get there. This is a keyword in JavaScript. You can see it's blue here, representing the fact that it's a keyword. And if I'm inside a function, inside my classic foo function, and this function is in the global scope, or it's just a function that exists anywhere like this, then by default this, the keyword, maps to the global scope, which in the browser is the window object. That's great, that's fine. I said before that if the function was a constructor, so if I capitalize it and then I call it using the new keyword, then this no longer refers to global scope. This refers to the object that you're constructing with this constructor function. So this mutates depending on how you call the function. It doesn't depend on how you declare the function. This is not a static declaration of what this is. It all depends on who calls you. So that may sound scary, because you go, well, I'm going to write my function making an assumption of what this is, but anyone else could call it, and then this could become that instead of this, and then my function won't work anymore. And yes, technically that is true, but most of the time you're going to be in charge of what's calling your JavaScript anyway, and it's generally just not a problem you have to worry about. So that's two ways we can make this do something different. The other one is that we can arbitrarily change what this becomes. So let's create a function called hello. In fact, I think I have a sample of this already. I do. So let's have a function called foo, which is going to alert this.hi. Now, by default, this function, this keyword is going to refer to global scope, because it's just a function on its own in the global scope in my script block. But what I'm doing down here is using the call method that's available on all functions in JavaScript. Now, I didn't mention before, I said JavaScript is object-oriented, and JavaScript has great function support. Functions are objects in JavaScript. They're functions and they're objects. So if I type foo dot, you'll see that foo itself has members, because it's not only a function that I can invoke by going foo open parens, it's an object that has its own members by going foo dot. And the prototype that foo inherits from is the core function object in JavaScript. And that's why I have a bunch of these methods here. One of those methods is the call method. So I can call a function by calling its call function, and then I can pass in to that call function whatever it is I want to be this. Whatever it is, I can just make it up. So in this case, what I'm doing is I'm going to call foo twice, and in the first instance, I'm going to pass in an object literal. So this is what these little squiggly braces are, remember? And it's an object literal that has a single member on it called hi, which is what I'm referring to in my, my function here. And in the first instance, it's a string called test. In the second instance, it's a number, 1, 2, 3. So if I look at this in my browser now, what we should see is I get test, okay? And then I hit OK, and I get 1, 2, 3, and Chrome telling me that I'm doing bad things because I keep popping up alerts. So you can see how this is mutating very, very simply. And again, this is really important because jQuery exploits this so that they can reuse this keyword in JavaScript depending on how you're using functions inside jQuery. So without further ado, that's our JavaScript fundamentals over. Anyone have any questions on that before I jump into the jQuery? Yes?
Did you skip closures?
I did, thank you very much. And you know why I skipped closures? Because I hate trying to explain them. Closures are one of those things that I've tried to explain it in talks like this over and over and over again. I still haven't boiled it down to a really succinct phrase. I think the documentation on jQuery actually has on the site somewhere one nice little paragraph that John wrote about what a closure is. And I should just remember that but I never do. So essentially, a closure is a function that references a variable that is not contained within its own immediate scope. I'll say that again. A closure is a function, for a start, that references a variable that isn't contained within its own immediate scope. So let's have a look what I mean by that. Let me get rid of this noise down here. Okay. So let's create a function. And outside of this function, let's declare a variable that isn't within the immediate scope of that function. So when I say the immediate scope, I mean this scope inside here. We have function scope, so everything inside the function is within the same scope because it's function scope. This thing is not inside the function, so I can't really get to it. But I can get to it, okay? Because this function exists in the same scope as this. So I can say my var, and I can see that. Everything's fine. Everything's good so far. Foo is in the same scope as my var, so the contents of foo can see my var. That's fine. So, but then what I can do is say, okay, I'm going to return another function. This is the easiest way to demonstrate this. I'm going to return a new function, and from within that function, I'm going to reference my var. No, I'm not going to do that. Let's do it a different way. I'm going to declare another variable in here. Aha. And we'll get rid of this one. This makes it easier to demonstrate. And inside this one, I'm going to I'm going to return the value of my var.toString. That's better. Okay, and let me just format that so it's easier to read. Okay. So what have we got here? I've got a function foo that itself is returning a function. Inside the scope of foo, I have a variable called myVar. And then the function that it's returning references this myVar variable as the return result. Now, this kind of looks, you go, okay, fine, big deal. What's the big problem here? You go, okay, well, what happens at runtime when I execute foo? Any language geeks, compiler geeks, runtime geeks will go, okay, well, foo is going to get invoked. I'm going to build up a call stack for foo. My var is now inside there. That's fine. And I'm going to return this function. Okay, well, I'm going to return a function that contains myvar.toString. Now, this isn't going to get evaluated at that point because what we're returning is this value, the function value. A function is a first-class thing inside JavaScript, so it's not going to evaluate that. It's just going to return the functions so it can get executed later. And then the function exits. So any scope inside that function, any stack, is torn down and it ceases to exist, right? Because the function is returned, I'm now gone. So what then happens, say I assign the result of calling foo to a variable called myfunc. So myfunc is now equal to this function. And then I want to invoke myfunc. What happens at that point? Well, now it's going to go and evaluate this line. And you see the problem now? My var doesn't exist anymore. My var only existed in the scope of foo, which is now returned. The reason this worked is because of closure. The foo, or the inside function, this anonymous function here, is said to close over the myvar variable which was defined outside of its immediate scope. And it will continue to live on as long as this function lives on somewhere in memory, in the stack somewhere. And in this case it's living on because it's assigned to myfunc. And as soon as that thing disappears, then the closure goes away and everything inside of it goes away with it. Okay? Now, this may look like a trivial example, but when we look at event handling in JavaScript, and jQuery in particular, this becomes really, really important because it's really built on the concept of closures. Any other questions?
Let's say, how do you get rid of the variable that you have there for myfunc?
How do you get rid of it?
Right.
So when the closure falls out of scope, so now that this closure, foo, the result of foo is a function that is a closure. It's assigned to myfunc. When myfunc disappears for whatever reason, because it falls out of scope, it's no longer there, then the closure just goes away. Garbage collection will take care of it. The JavaScript runtime will do its cleanup.
Oh.
Okay.
It's right after it's been executed.
Well, not necessarily after it's been executed, because executing myfunc doesn't make myfunc go out of scope. Myfunc is still there. I could execute it again. Okay? And if myfunc did something funky, like mutated the value of myvar, so rather than doing this, maybe I change myvar to equal myvar plus 1, and then I execute it twice, the second result will be different to the first one. Because myvar is living on as a variable, not as a value. Okay? And that's another important distinction, because one of the classic problems with closures that people get into is the for each problem. When you for each over something, a set of values, and then you assign that value to something that's a closure, inside a closure, and you expect the closure to have closed over the value. So you say you created 10 things, 1 to 10, you shove them in, and then later on you go to execute the 5th one. What you'll get is the value of the 10th one. Because you don't get the value you closed over, you get the variable you closed over. Because as I said, this doesn't get evaluated until you execute it. And at the point that it's evaluated, myvar is equal to whatever it was at the very end, not what it was when you assigned it. And the way you get around that is doing something called a double closure. And you can look that up. You will run into it eventually, and when you run into it, you may waste hours trying to figure out what it is. And once you've seen it once, you make a promise to yourself that you'll never run into it again.
So if you assign something to myfunc, like null string, that would cut it loose.
Sorry, say that again?
If you made an assignment to myfunc.
Yes, exactly. So if I now said myfunc, because myfunc's just, even though it's a function at the moment, it could be anything else. Now the value that was on myfunc now is gone. It doesn't exist, it's not identified, assigned or anything more. Assuming that your JavaScript runtime is doing the right thing, it'll disappear. There's no way to get it back now anyway. It's not assigned or anything, it's just floating in the ether, and it'll get cleaned up as appropriate. Any other questions on JavaScript fundamentals? Yes?
What's the difference between call and apply?
Call and apply. It's very trivial. One allows you to pass in the arguments as a list, but just by defining the arguments as extra parameters to the method itself. The other one lets you pass in the arguments by passing in a parameters collection, which is a special thing in JavaScript using the arguments keyword. So you can pass it in that way. It's kind of hokey they did that, but that's why there's one. That's why there's two: call and apply. Anything else? Yes.
You said that myvar was an object.
Yes.
Say a user record.
Sure.
And it was returned and assigned to a variable.
Yep.
And then you got rid of myfunc.
And then you got rid of which? Sorry.
Okay. First name, last name.
Okay. So let's just say it has this.
And then instead of returning a string, you return myvar as a straight value.
Yep. We get rid of this.
And then you say, down in line 43,
Yep.
u equals myfunc.
Yep.
And at that point, is it impossible for the closure to get rid of this loop?
Is it impossible for the closure to get it out of scope until you get rid of the U? That's a very good question, and off the top of my head, I don't know. These ones always do me in. JavaScript is by reference, not by value in all cases, I think.
So the view over there is a reference to the myvar.
Yep.
But the myvar doesn't actually reference the function.
Right.
Basically, as long as you still have access to that first name, but the way you should think about it is, let's imagine that it did happen, right? Let's imagine that it did disappear. Would that cause any logical problems? And the answer here is no, right? Because the myvar doesn't reference the function.
Yep. So my answer to those things is try it and see what happens. And try it in more than one browser, because don't be surprised if it works differently in different browsers. When you get into these edge cases of passing things by value or reference by default and things like that, sometimes you find they do different things. So, any other? Yes?
One more clarification. If you have myfunc2 equals foo,
Yes?
you get a second myvar.
So if I do this, they will be the same var, I believe. I'm looking for someone to correct me. I think that's correct. They will be the same var. Because it's the same. It's closing over that variable. It's not closing over a value that gets duplicated. It's closing over that variable. And that variable is my var. So you're going to get the same thing. Again, we can try that. And if someone wants to try it with a laptop now and prove me wrong, great.
JavaScript, nothing ever gets copied.
Nothing ever gets copied in JavaScript. There you go. That's a canonical rule to put on your post-it note on your monitor. JavaScript is great, and underneath that, JavaScript, nothing in JavaScript is ever copied. Okay, so let's get back into jQuery then. I could talk about JavaScript all night, but jQuery is what we're here to learn about. Okay, so the hello world of jQuery. I have an HTML page in which I have a reference to jQuery at the bottom. Yay! And then I have some script at the bottom there. And what I'm going to do is I want to push hello world into this page. So I'm going to use I'll zoom up a bit. I'm going to use the jQuery. I'm going to use the word constructor, but it's kind of I shouldn't really, but it's just easier to refer to this as the jQuery constructor. The jQuery constructor you can invoke just by typing jQuery, but no one does that. Everyone uses the $ shortcut because that's cooler and it's less characters. So jQuery, and then inside this I'm going to pass a function. Say, whoa, hang on. Function. Okay, so here we're starting to see those things that I've just been talking about come into action already. The jQuery constructor will mutate its behavior based on what you pass into it. Another thing about JavaScript I didn't talk about is that there are no function overloads in JavaScript. In object-oriented languages that are statically typed, you might be used to going, well, function foo, when it takes one parameter is this, and when function foo takes two parameters, it is this. That doesn't exist in JavaScript because objects in JavaScript, including function members, are just an identifier and a value. You can't have the identifier twice mean different things. So the way that you do function overloads is you say, function foo, p1, p2, and then you just, if you wanted to do something when only p1 is there, you just check for the existence of p2. And if p2 is there and you do something, and if it's not there, then do something else. And now, it's not just if it's there or not, you can check its type, or if it's all a string, you can investigate the string, and basically you can mutate what foo is going to do based on what gets passed into it. And even if you don't declare the parameters, you can get to the parameters because JavaScript has a reserved word called arguments that represents everything that was passed into this function when it was invoked, even if I didn't declare them in the function signature. Very, very cool stuff. So jQuery uses this. So you can call the jQuery constructor with a whole bunch of different parameters. And the one I'm showing you now is a function. If you pass a function into the jQuery constructor, what it will do is run that function when the DOM is ready to be manipulated, when the document ready event is fired. What you'll generally see most introduction tutorials do is this. They'll pass in the document object, and then they'll use the ready function to wire this up. And then there's just so much more typing, really? I mean, why did you have to do all of that when I could just do that, right? So now, anytime you see that, just delete it and do that instead, right? It's less characters. It's much better for the environment. So, this is going to execute when it's safe. You don't want to be executing stuff before the DOM is finished loading. Why? What happens if you try and manipulate the DOM before it's finished loading? Yeah, it does different things depending on what version of the browser and what browser you're in, but it's just bad in general. IE6 will actually crash in a lot of circumstances because that's what IE6 does best. And so you really don't want to do this. Make sure that you're always doing your code inside here. The other advantage of doing this, has anyone spotted what the other advantage is? If we go back to here and we look at this thing, Where did I keep it? I deleted it. That was clever, wasn't it? I've protected the scope. Excellent. Give that man a cookie. I have protected the scope. Anything I declare inside here only exists within this function because I have function scope. I'm not polluting global scope. Now, jQuery as a library will never pollute the global scope except, obviously, for the jQuery member itself. Obviously, $ has to exist on the window object so you can call it. But you should be able to do everything inside of here and never have to have stuff outside of here. If you have stuff outside of here, then I can't help you. Do it inside here. Things are much safer. Now that we're inside here, let's actually do our hello world. So what I want to do is I want to find the body tag, which I do. Now I'm passing a string in. I'm not passing a function in, I'm passing a string. When you pass a string into jQuery, it says, oh, this must be a CSS selector. I'm going to invoke that wonderful Sizzle CSS selector engine that we heard about before and find all the elements that match this selector. Now in this case, there's only one element that matches the body tag. So what I'm going to get is a jQuery collection with one element in it. And then to that collection, I'm going to append some stuff by calling the append method. And in this case, all I want to do is append hello world. So I'm just going to literally type that in. We'll view that in the browser. And what we should see is hello world. The world is happy. Now, I can also type HTML in here. And if I hit F5, jQuery was clever enough to figure out not only is this a string that I've passed in, but it's a string that looks like HTML. And so it's actually parsed that into DOM elements and then injected it and escaped it correctly for me into the DOM. Which is really, really cool as well, because if you try and do this using the raw DOM API, you'll have blood on your fingers before you finish typing it all out. So that is our hello world of jQuery. Very, very, very simple thing to do. Let's move on to selectors. So I left that with when you pass in a string to the jQuery constructor, it assumes that what you're passing in is a selector. Now, if you want to be a great jQuery developer, you really need to brush up on your CSS selectors. But don't worry, because as soon as you start writing jQuery and you look at jQuery samples, you'll just start absorbing CSS selector goodness, because that's really where the power of jQuery comes in. The fact that it lets you find stuff in your document using the wonderful, wonderful CSS selector language. If you don't like CSS, then get out of the last century and get into here, because that's where it's really, really at. CSS selector language is perfect. The perfect language for expressing a statement that says, go find me stuff in the DOM that matches this, and doing it succinctly. Yes?
Going back to what append was, so that stuck in the effect was put in a new child.
Yes.
Okay.
In this case, append was appending a new node into the DOM, and it was figuring out whether it was a text node or an HTML node or whatever it is it needed to do. So let's have a look at different types of selectors. So the first one I showed you was fairly obvious. I just want to find elements that are of a particular type. So before I do that, I've got a basic document here. I've got some divs, ULs, some anchor tags, some spans. I've got class attributes set on some. I've got some anchors. I've got some Ps. So let's say, let me find all the anchor tags. And then once I've got that collection, all I'm going to do for the purposes of this demo is add a CSS class. And I've actually declared a class at the top of this file called highlight, so we can see that when stuff's been applied to it. So find me all the anchor tags and then add the CSS class highlight to them. So if we look at that in my browser, and I hit F5, then we can see that it's found all the anchor tags and it's highlighted them by adding the CSS class highlight. That's pretty easy. Let's do something different. What about class? Well, if you know your CSS selectors, you'll know that you use the dot, the full stop, to denote the fact that you're looking for a class, and then you put the class name. And I think I have a class name foo in here. So if we go back now and hit refresh on this, I've got a couple of elements that have a class name of foo. Here I've got a span, and here I have the whole li, so it's found both of those nicely for me. If I want to find something by ID, I can use the hash or pound or whatever you call it in your neck of the woods, to find something by ID. And if I remember correctly, I have something up here called nav, so I can change this to say, find me the thing with an ID of nav, and hit F5. And now it found that first UL because I gave that an ID of nav. And that's all the simple ones. But jQuery actually supports a whole bunch of much more complex selectors, commonly referred to as CSS3 selectors, or even CSS 2.1 selectors for that matter. It's just that IE didn't get them until IE 7 or 8. So if we do something like, let me find all the A tags that have the rel attribute defined. And if I look up at the document here, we'll see if I scroll across, I have an anchor tag here that has the rel attribute defined to a value of external. So if I just say square bracket rel and don't put anything else, it's just going to find anything where rel exists. As long as rel is even declared, this is going to match. And so now if I hit F5, you can see that it's found this link down here because rel was declared. If I want to be a little more explicit, I can say, well, where rel is equal to some value. So I'll say rel is equal to external now, which is what I've declared it to. So that should find it, which it did. If I change that to something other than that and hit F5, it's not going to find it this time. Now, you can do quite advanced things. So you can say anything that starts with ext. I think that's the correct one. Yes, that found it. Or anything that ends, use a $ with NAL. Okay, they found that as well. Now, again, it might look a bit strange, but this becomes a lot more useful when you're doing things like this. And you say, well, find me anything that ends with JPEG. And now you can find all the links that link off to a JPEG. Or find me anything that starts with HTTP. Now find me all the links that aren't internal to the site. Anything that goes off to a different website. All external links, okay? Now, for those who are really quick, you would have noticed that the characters that are used here are anything that's begins and that's ends. Where do they come from? Regex. I didn't know that until someone pointed out to me last week. I always had trouble remembering which one was which. And now I'm like, oh, look at that. So there you go. There are some other ones. There's the tilde as well. This is where I forget which one does what. But essentially there are a bunch of different prefixes to the equals operator you can use to say if the attribute accepts a space delimited list of values. Now the only one really that does that is the class attribute. Then you can use, I think it's tilde, it's one of them, to find anything that has a single instance. If it takes a comma separated list of values, you can use a different operator. If it takes a hyphen separated list of values, which is generally the lang operator, where you might have something like en-us, or you just want to find anything where lang has n in it somewhere, then you can use an operator to do that. There's a set of those in CSS 2.1 and there's some further ones in CSS 3, and jQuery supports them all. So that's really kind of cool. Some other ones, we can then do some funky stuff like filters. So this one here looks like what I had before. So we've got this colon in here now. So what I'm saying is I want to find all the li elements that has something else underneath it. And there's this semicolon is used to denote what's called a pseudo class. So I can say, get me all the li's that are even. So if I hit F5 now, it's gotten me the first one. That's strange. Well, it's 0 based, so it's 0 and 1, 0 and 2, and 0 and you get the idea. And of course, I can do odd as well. And that's going to get me the opposite. You can get really funky, so you can say like nth child of 2n plus 1, and that will do something. Well, that just did what I did before. Let's make it -4 or something. Let's make it n minus 4. I don't know what that'll do. Nothing. Oh, I got all of them, right. So you can. This is basically a way of expressing an equation used to find children using some formula. So you can use this to get me every 7th and 5th item, or the 3rd last item plus whatever. You can do crazy stuff in here to find very, very particular items. You can do last child of type. You can do first of type. All types of wonderful stuff like that. Now, a lot of these are, again, standard parts of CSS 2.1 and CSS 3, and there are some stuff that jQuery has actually added themselves. And you can even put your own ones in there. I actually have a sample here. This is a plugin that I wrote. We'll get to plugins later. Called Track Dirty, and one of the things it does is it adds a new selector using this tiny incy-wincy bit of code down here, if I get rid of that. So just this little block of code here adds a new selector that can then be used inside jQuery. So I just say $.extend jQuery.expression : and then I pass it an object literal, and I give it the name of the thing I want to extend it with. I want to add one called dirty, and then you just give it a function that's a predicate, basically a function that returns true or false given an input when looking at characters of that function. And then the way you would use this is something like this. So I can say, find me the dirty elements, just by saying : dirty. Okay, so jQuery is immensely extensible, and it's not just because it's JavaScript. I mean, JavaScript is loosey-goosey, dynamic. You can basically replace anything with anything else, which basically means anything is extensible, but there's a cost because you might have to completely re-implement something to extend it. jQuery, in most parts, is built and engineered to be extensible. So rather than having to completely replace a section to make it do what you want, they give you hooks to enhance what it can do. And a lot of the best plugins aren't fancy light boxes that are 100 lightbox plugins or fancy new animation effects. They're just minor tweaks that they've made to jQuery to give it further building blocks or make it support stuff that jQuery core doesn't. One of the ones that we mentioned before was the rotate plugin, which extends the CSS stuff to support the new rotate CSS transform. It really is built for extensibility, which is why the plugin community around jQuery is really so vibrant. And of course, you can join these things together. So if you want to find all the LIs and all the A tags, and turn off my caps lock, then you just do as you do in CSS. You separate them with a comma, and now it'll find that's one selector, and that is another selector, and it'll just concatenate the result. And if I look at that in the browser, at F5, I should find all my LIs and my A have been highlighted. So that's the introduction to selectors. Any question on selectors before I quickly move on? 10 minutes. Nope, then I'll move on. Events. Now, events has got to be one of the most painful things to do when doing DOM programming, especially across browser. The main reason being that up until IE9, the main browsers out there, IE and everything else, did events totally differently. They use a completely different API for managing events. Now, there is a reason, and if you want to know the history of it, watch Douglas Crockford, he explains it. There is a reason it's like that. There's really no good reason why IE didn't update to support the better stuff later, but there's a reason why it was the way it was. So jQuery is great because, as we heard before, the biggest part jQuery really does is it creates an abstraction layer over the DOM, and events is just one core of that. So here's the real basics. I've got a page here with a few things on it, a few interactive elements that I want to show you. If you look at this in the browser, what we have is a button, I have a checkbox with a label, and I have a bunch of links. And I'm going to wire up some behavior to these elements using jQuery and the event handling stuff. So first of all, I'm going to say, okay, I'm inside my function load here, remember? I'm going to find the click me element, that is the element that has an ID of click me. I'm going to call the click function, and I'm going to pass to the click function a function. So this is going to be my handler. Now, this is an anonymous function, otherwise known as a lambda, otherwise known as a callback in jQuery parlance. They usually call these callbacks. This is the function that will be called when the click event happens on the click me element that we've found. And so when that function gets called, when the click happens, I'm going to run some more jQuery. I'm going to find this result element, and I'm going to append you clicked me to it. So if I go up here and clicked me, you can see that every time I do that, it's just appending you clicked me to that element. Easy as that to handle a click element, a click event. If we want to do something a little more funky, I've done the exact same thing here, but now I'm doing it for all the anchor tags under this links element. So that's this thing here. I've got a list of links, and I'm handling the click event. And this time my signature is taking in a single parameter. This parameter will be populated with the event object. If you've ever done event DOM programming, you'll know what the event object is. You'll know that it's different in every browser. You'll be happy to know that jQuery has their own event object that abstracts the event system in all the browsers. So this E object is of type jQuery.event, and it has a bunch of methods on them. One of them is the prevent default method, which stops the bubbling of the event up through the DOM. So I'm calling that because this is an anchor tag, and if I don't do that, it'll navigate off to whatever its href is set to. And then I'm going to append another item to the same list of items that I clicked on. So if I click on this, I click on these links, I just keep adding more links. Now, only the first 4 links will work because all these new links that I've added don't have that handler on them. If I look at my code again, I'm going, okay, well, find me all anchor tags, all anchor tags under the links, and then assign a link. Okay, well, when this executed, it only found the 4 original ones that were there, okay? And so then it assigned that click handle to those. I went and added a bunch more. Now, you might have done this via Ajax, or you might have just done something in JavaScript to build up some type of DOM. You might have used the templating plugin to build this up. And so your handlers aren't going to get attached automatically to those new events. So the way we can get around that is using something called event delegation, otherwise known as live binding. So I'm going to change from using the click event method to the live method. And that's all I had to do. I'm passing in the click event name to the live method. And now this is just going to work. So if I hit F5, and I start clicking these, I can click any of these new ones and this will continue to work. And the reason that is because rather than attaching this event handler to all the events that it found, it attached the event handler way up in the DOM tree somewhere and then used event delegation when the event bubbles up from any event that matches this selector to figure out that it's one of those elements, and then process that click handler. So it reduces memory consumption because obviously you're not attaching handlers to all of these DOM elements. You're just doing it once. And it means that you don't have to reattach handlers. It just does it for you automatically. The other one is working with mouse events. This is notoriously difficult to do.
Simple question.
Yes?
The usual problem for events, then you remove elements from DOM.
Yes?
It's often give a reference
Yes.
to listener.
Yes.
So how jQuery deals with remove?
So if you use the remove methods in jQuery to remove them,
If I remove link, what happens?
if you use the methods in jQuery to take those things out of the DOM, it'll clean those up for you. And you can manually unbind the event handlers as well. Most browsers these days will take care of all that for you. You don't have to worry about it. IE6 was the real big problem.
Usually has goes into memory leak.
Yeah. So most modern browsers that I know of now don't really have this problem anymore. As soon as the DOM element is removed from the node, it'll destroy all handlers on it. But you can manually unbind them. So you can, instead of saying live, you can say kill, and that will kill the event handler. And if you bound it originally using bind, you can say unbind, and that'll get rid of it.
You don't have, like,
But you don't have to do that.
you said.
As I said, you don't have to do that. If you remove it using remove, the elements from the tree, you don't have to worry about it these days.
Basically, if you do any kind of DOM manipulation that
Yep.
results in the element getting removed.
Yeah, it'll just take care of itself for you. So mouse events. I mentioned the event object that gets passed into your event callbacks. That also has a bunch of great properties on it that tell you details about the mouse cursor. Here, I'll just zoom out a bit. I have a track mouse button that when you that checkbox, this thing here, that when you click it, I'm going to check if it's checked, and if it is, I'm going to wire up the mouse move event on the HTML node, and when I detect that the mouse has moved in the document, I'm just going to go and basically update a bunch of properties on the page so I can track it, and I'm going to update the position of something to match it. Else, if it's not checked, I'm just going to unbind that. So this is a situation where I'm physically unbinding that event because I want to let the user toggle the usability on and off. So if we look at that working, the moment I hit track mouse, and we can see now that I've got this little DOM element that's following the mouse around. If we look to it a bit slower, you'll see that the numbers inside are being updated to the cursor position of the current mouse cursor. Now, I know I've calculated the offset based on the cursor and stuff, but that's the code here. Like, it's really quite simple to do using the jQuery eventing system. And this was notoriously difficult to get to work across browser before things like jQuery. Lastly, I've only got time for one last thing, I think. Animation. The animation in jQuery is very rudimentary. It's very basic. I mean, animation at its core is one very basic concept. Take a value in its current state, get it to another value over a period of time using some function to increment the value along the way. That's all animation is. Now, you can get more complicated with automatic tweening and things like that, but jQuery is just about changing one value from this to that over this period of time using this function. And the things that you're animating, the values of CSS properties. Now, I just have a sample page here that basically builds up a series of animations. So as I click on this thing, it moves around and does stuff. The code is a little bit fancy because I generally build up to the stuff, but it's really not that much code. Essentially what I have here is an array of objects that represents the animations I'm going to do. So I'm going to animate the left property to 400. I'm going to animate the top property to 200, etc., etc. And then I've got a function called apply effect, which I give it an effect, which is one of these things, and then the element I want to apply it to. And then down here, this is the thing I'm clicking on. When you click on it, it basically just says, hey, call this next effect function, find the current effect from this array, move to the next one, and then call apply effect. And the actual core of what we're looking at is this animate function here. So this $L is an instance of a jQuery, is just a variable name I created, but I know that that's a jQuery collection, and I'm calling the animate method, and I'm just passing in what it is I want to animate. So animation is very, very basic in jQuery. There are great plugins that will add better easing functions, so rather than just animating in a linear fashion, you can make it go slow and then fast, or fast and then slow, or go beyond and then bounce back, or use elastic and do types of wacky stuff like that. There are other plugins that let you animate color, so you can go from red to blue. By default, jQuery won't do that, but there's a very simple plugin that will do that for you. So with that, I'm out of time. So hopefully you've got something out of that. If you want to learn more about JavaScript in general, check out the YUI Theater. So if you just type in YUI Theater into your favorite search engine, click on there and look for Douglas Crockford stuff, anything by this guy here. Watch everything that this guy does on here, and you'll become a billion% better JavaScript developer. I can't overstate that enough. Otherwise, grab me after if you've got any questions. Thanks for your time.
Perfect. All right, Yehuda, Damian, awesomeness. Okay, perfect. So we are at around, what time is it? It's 8. Let me bounce back to the schedule so keep everyone on track.